So in example 2, we're given some properties of a function and we're asked to sketch a graph. Okay, so I'll just kind of start with some axes here. And let's see what these properties are that they're giving us. So it says that f has a critical point at x equals 4 and an inflection point at x equals 8. Okay, well, let's mark off the graph here, or put a scale on this graph. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 and there's 4. So we have a critical point. So that means it's either a maximum or a minimum, or maybe neither. And an inflection point at 8. So we have a change in concavity at x equals 8. All right, well, there's not much we can graph at this point. Let's look at the next property. The value of the first derivative, f prime, so the slope of the function is negative to the left of 4 and positive to the right of 4. Okay, so it's negative, so that means the first derivative tells you the slope of the function. So it's decreasing, right? The function is decreasing to the left of 4, and it's positive to the right of 4, which I assume means everywhere to the right of 4. So I'm actually going to have just because I got the 8 there, I want to make sure that it's clear that everywhere to the right of 4, the first derivative is positive, which means it's an increasing function. All right, and then finally it says that the second derivative is positive, so that's concave up. So it's concave up to the left of 8 and negative to the right of 8. All right, so that means it's concave down. So let's kind of we could take these arrows and curve them. So if it's positive to the left of 8, so that means everywhere to the left of 8, it's positive and it's concave up. So that means the curvature, in this case over here, it's decreasing and concave up, so it's going to have a curvature sort of like that. And then here it's increasing and concave up, so it's going to have some curvature that looks like that. Now, and so then we have this inflection point at 8. So I'm going to mark this IP and CP for critical point and inflection points, just so I remember that. So again, it's to the right of 8, it's negative, so it's concave down. But it's concave down and increasing, so it's going to have some curvature that looks like that. All right. Well, let's see if we can graph something that has those properties. Okay, so it's concave down, concave down everywhere between to the left of 8. And let's put in a point. So let's say that the critical point. Now we don't know any actual point, so let's just say we have a point here. The x equals 4 has some function value about there, and it's concave down, and it's decreasing. Right, so it kind of comes in like that, and then it's still concave down, but it's increasing between 4 and 8. So it has some curvature that goes like that. All right, up until 8. So let me kind of sketch in where 8 would be. Okay, so my graph isn't. I'm going to run into my words, but you'll get the idea. Okay, so it's concave up, and then it changes. It's still increasing, but it's concave down. Okay, so it's going to change concavity and have a curvature that looks more like that. All right, so I ran into my words, but that's okay. You get the idea. That kind of gives you a sense of the shape of this graph. So, so we're just sketching it, right? We're just sketching a graph. Now, again, like I said, it's just kind of giving you a general idea of the shape of the graph. And you can see too that here we have a local minimum. Local minimum. Okay, so why do we say it's a local minimum? Well, it's a critical point, and it changes from decreasing to increasing. Okay, so that's telling us that's a local minimum. And then we were told there's an inflection point here. Inflection point, and it's changing from concave up to concave down at that point. All right, well, that's all I can really say about that. So I'll meet you in the next video.